to the session. Greeting of the day. In the last session, we have seen about what is meant by system. It means a box. We have seen last class we have seen about system. Last class we have seen about system. In this we have seen about the measurement system. Measurement system, and then control system we have seen. Control system. In control system, we have divided into two categories. One is open and one more is closed. In this open, we have mentioned a system which is nothing but a box which contains an input, and one contains an output. In this box, a system, this will contain three parts of control unit, process unit, correction unit. Right? These three we have seen in the previous classes. Now we are going to add in the closed loop, it means a closed system, we are going to add a feedback measurement device. We are going to add a feedback measurement device which is going to be a closed system. There, in the open loop system, we won't get the feedback what happening outside at the other end. That we need to identify what happening, and then we should rectify the error, or otherwise there is no use. For example, we have taken a water filling tank, switched on. If the water is filled, again the switch is to be off. If the feedback comes, it is filled, then it offs. If the feedback is not comes, what happens? The switch is not off, the water levels are wasted out. Therefore, we are adding the another two parts here. We can tell the main elements of closed loop system. From the open loop, we are coming up over to the closed loop. We are adding some two elements here. Earlier, we have these three parts. These three parts we have for the open loop. Open loop. It means the upper part, the control, the correction, the process. Only here we have given an input here, we have given an input here, we have given an input here, and we have taken an output here. Right? This measurement loop feedback system, closed loop system is not there. This only three parts are there. That is what I have mentioned here: control, correction, process. Control, correction, process. This top line, the three. Now additionally I am adding this two. Now I am additionally adding this two parts. I am adding this two parts along with this. Now it will become a comparison element, a first one, then the control element, then the correction element, then the process element, and we have a feedback system of measurement, otherwise known as feedback system. So it become a closed loop system. So we will go ahead, what is these elements, what it does, and we will go ahead with the example. Right. Number one, we are seeing about this comparison element. So this compares the required or reference value of the variable conditions being controlled. It compares the required. The required we have given here, the input. We need the room temperature, or we need the tank water level. Such things we are giving. Let us consider temperature of 22 we are giving here as an input. This is the reference value we need, we are giving. Or the reference value of the variable condition being controlled. This is to be controlled. With the measured value. What is the measured value we are getting? We are taking output here. With the measured value maybe a 23, 24, anything. Any cases, any temperatures. So of what is being achieved produces the error signal. Okay. So here we are, the comparison element want to compare with the reference with the measured value. Here, measured value we are taking at the output, and we are comparing here. This is the comparison element which compares the 22 minus 24. What as the 2 is the difference. So we have to control and correction to be done here. This 2 to be correction to be done here. So the comparison element compares. So we can able to hear the definition. We can tell the error signal. Error value is equal to the reference value minus the measured value. The reference value is 22. The measured value is 23 or 18 or 20, whatever it is. The compares and the feedbacks and gives comparison element gives the signal to the controller. Gives the signal to the controller. Those things again you have to modify. Right. So see, next control element. This is number 2. We have seen this one. Comparison element we have seen number 2. This one. So this decides what action to take. This decides what action to take when it receives an error signal. From where we are receiving? These signals are received from the comparison element. The signals are received from the comparison element. Comparison element. It means from before. This one from here to here we are sending. From here to here we are sending now. But what is that signal? Signal may be to operate a switch. If the temperature is low, you have to operate a switch of 1 kilowatt or 2 kilowatt to run the AC. If the water level is low, we have to operate the switch to switch on the water. Right? Or otherwise, or a signal, the same signal. This is to operate the signal, or a signal to open the valve. If the water level is low, you have to open. A sensor, a switch. If the AC is low, we have to on to increase the temperature. Whatever is. A signal may be to operate or off, on or off. It is a signal we are giving to the controller. This controller information you have to give to the correction unit. Right? You see. You see, the correction element produces a change. Now here the changes occurs. We have received from here the comparison. We have received. Then the signal processed, whether a signal to switch on or switch off. The switch is here, right? It is to be on or off. This we are seeing here. Produces change in the process to correct or change the controlled condition. We understand. It might be a switch. That is what I told you. It might be a switch. A switch on a heater to increase the temperature. Here we are sending a signal to decide. The switch is here. The correction element is a switch. Here it may be a person. Control element is a person. I need this. I am in the room, in the AC. I need this. I am the person. I am the controlling part. I am switching on. The switch is here. I am the person. Error is received here. Right? A switch on a heater to increase the temperature, for example. And maybe to open a valve and allows more liquid to enter the tank. If it is reduced, switching on to on the motor to run. If the AC temperature is reduced, switching on to increase the temperature. Right? Here the correction unit, the switch. Now, the process element, the last one. So we have seen this one. We have seen number 2 and number 3 the switch, the correction element, and finally the process. Maybe a heater. When the switch is on, the heater on for room increasing or decreasing. Right? A motor is on, the motor functions to increase the water level or it will off. The process is what is being controlled, the motor or maybe a AC, electric motor or heater we can consider. So, for example, I have given here a room in a house with the temperature being controlled. So here sometimes we control the temperature, sometimes we control water. For example, we have taken 2. A tank of water with its water level being controlled. A room in a house with the temperature being controlled. Right? A temperature or a water. For this two examples we have taken. So on this, next, a last one. This one. The output came here. The output came. So this output to be measured here. Again, what it is. So here, number one, I am repeating because it is as it is a continuous elements, we want to talk in related to that. So comparison element, the received output signal received are measured here. Then these measured elements are given to the comparison to find the error. To find the error signal with respect to the reference. We have wanted that error equal to reference minus the measured value. That is error. Okay, those error signals are given to the controller part. This may be a person. I am writing it. This may be a person. To switch on a correction element, a switch. Right? The process element may be a motor or what? A heater. And then we are measuring output, a thermometer or Untitled generator, speed measurers, whatever it is. Right? Level measurers. Okay. So there we are measured, and here the measuring device may be a thermometer, maybe a Untitled generators, right? Or speed measurements. Right? So there is such things are again connected to the error signal. It is a closed loop cycle. If these three are having open loop, if additional two we are adding, it will become a closed loop. Right. So we are seeing here whatever I told you, we are seeing as some example. So room temperature with the central heating. We have a system. Here we have a system. Here we have a system. The system contains a furnace and its control system. This inside we will have. What are they? A control, then the correction, then the process. Very important question. Repeatedly asked, what write about the closed loop, write about the open loop. These two comparison with example you should. A control, correction and a process. So here, this side we have input, that side we have output. It looks simple. It looks simple, but there some elements we may miss sometimes. We should remember these things. So similarly, what happens? The room temperature are measured. The feedbacks are given to maintain the desired required level of room temperature. One example. So here, pick up a pencil. In the first session I told you to operate a pen in the pocket. And leveling should not move towards the wrong decision. It should have feedback in such a way to move the pen to this specific location. So that is what? A control system for hand position movement. So as like that here also input, as like that the output, and the three components of control, correction and the process. Here as usual we have a measurement, and additionally we will have a comparison element. So required hand position, we are giving the required hand position. Hand position towards the pencil, where it is moving, this actual position is to be monitored, and this has to be given as a feedback. This feedback to be reaches the system, the box, and it controls it again. See, I have taken for the consideration of a room temperature measurement, the same example what we have seen in the previous slide. A room temperature measurement. Here I have compared what we have talked or written there, I have sketched here. You see, the control unit. We can mark here. The control unit as a person, a correction unit, a connection unit, as a switch, and then a process may be an electric fire. If 3 is there, then it becomes an open loop. We are not talking about that. We need a closed loop system. We are not talking about that. Now, additionally, output is coming, a measurement device, right? A measurement device may be a thermometer, I told you, type of generator, whatever. Something, whatever we are measuring, that is it, that belongs to a measurement device, and it is connected to the comparison element. A room temperature measurement system. What happens here? To maintain the temperature of a room at a constant level, what we need, as I told you, the feedback system may be a thermometer. I told you. This may be a thermometer. Right? So, and then a switch may be a 1 kilowatt or a 2 kilowatt element to on or off. So, here the controller person may switch on a 1 kilowatt power here. It may be a 1 kilowatt or otherwise a 2 kilowatt to operate. What happens? To increase the conditions of AC, to increase the conditions of heating levels. 1 kilowatt low heating, 2 kilowatt high heating points. Temperature increases as and the heater. This two we need. That is what we are seeing. In this situation, there is a feedback in input to the system being adjusted according to whether it is output is matches. So this technical what it is telling here, it should match what temperature we need. This 22 should match. The given 22 should match there. Until then, it processes. Until then, it is going to get processed. The feedback gives and goes. This means what? The input to the switch depends on the which one? The input depends on the output here. But there in the open loop, it is not dependent. The input something is given. Due to some dynamic changes, some output are already changed. But we are not monitoring. Those systems. But here, the switch is dependent on, input is dependent on the outputs. It is to be controlled. We need 22, output is 21, and it is measured, and again it is controlling action has been done. Therefore, it is dependent on the output to what has been actual, the temperature from the required one. The error, it means the error. Okay? The error is the difference of measured output and the set value. This we know. These things we know already. Error equal to the reference or set value minus the measured one. Reference equal to the difference between the measured and the set value of the reference value, whatever it is. The difference we are comparing here. Okay? You see. We conclude here. It means whether we have seen the elements I have done in one direction, the parts I have given the other one. For open loop, I repeat, for open loop, we need the control, the correction, the process. Only 3. These 3 we need, the top 3. In the closed loop, out of 3 we are adding one more 2. The measurement and the comparison. So we are here. Now we are discussing about the closed loop system, an example of temperature measurements. So see, the control variable, the required temperature is measured, is controlled. The room temperature is maintained. The desired level. Who is the comparison person? Myself. A person. I am comparing. Right? It is a definition, error. A difference between measured and the required. This we know. Difference between the measured and the required. It means the difference between the set value and the measured value. This we know. Which is the controlling unit? The person. I am going to control here. Comparison. I am going to compare. I am the person. Whether it is much more cooled or not. I decide and I change. Right? Maybe automatic. Maybe automatic. A correction unit. A switch on. Correction unit. Switch to be a 1 kilowatt switch or 2 kilowatt switch to on the fire. On the electric coils or power, whatever it is. A process unit. What is processing? The heating. Process is the heating. Let me understand this. The measurement device, which one we know this? Thermometer. Right there, in an example of water level, the water to be taper generators to be measured as speed. In the shaft rotation, those examples we'll see. So measurement device is the thermometer. So this is how. I repeat, see, I repeat here. So here, from here to here, it is open loop. And we are adding these two components, it become a closed loop. Very, very important. With example, write about the elements of closed loop. Right? Right. So what are the advantages we are seeing in the closed loop system? The feedback is the main important advantage here. Or otherwise it won't help. What happening? We will not know. Right? See, mostly used a system in almost all automobile industries. Accuracy is maintained. There, the accuracy is not maintained. Here, accuracy is maintained and automatic also. Accuracy is maintained and automatic. Accuracy is maintained and automatic. Right? Control action based upon feedback. For this purpose only, we are using the closed loop. Control action based upon the feedback. So here again I am repeating the feedback control system. Okay, this is not available in the open. Please remember. Please remember. Disadvantages are the system is complicated. We understand easily, but the system when the elements are increasing, the complexity also increases. That is what here mentioned. We understand easily. The three components belongs to open. Additionally, measurement and comparison belongs to closed. We understand. But by the system, it is complicated and expensive. When the element increases, cost increases. So importantly, the advantage is here the control system based upon a feedback which is useful to maintain the accuracy. Disadvantages is become complicated and expensive. Right? But even though we are using this one, we are using this closed loop is everywhere we are using as we need feedback. If you are not bothering, definitely error. If you are not bothering, definitely the decision goes wrong. The output won't comes. Right. So we have taken one more example. What we are keep on telling. One we are keep on telling about room temperature as an example. One we are telling one more example of water level maintenance. There I have taken the same image. See, one side I have taken elements. What are the elements are there? On one side I have taken the conditions. What it happens. So the controlled variable is we know. We are going to control the water level of the tank. It means the inside setting to the float level. What happens here we see? So we have a tank. There we have a float, a lever, and here the pivot is there. You see? Here the pivot. Here the pivot is there. Right? So when it opens, the flap opens, it closes. Here it closes. When it is straight, it closes. Water won't come in. When the water level reduces, it opens up. It opens. Then what happens? Automatically the flow of water level comes in. Right? So we understand this simple mechanism. So even though here also the closed loop system are there. So control variable water level in a tank, and then the error signal. We know this definition. We are not going much more in the difference between the actual. What is here? The actual and the initial level question. This one. This question we name it as a error. So again we have to fill these things. So comparison element, the lever, where the lever is, whether at the top or at the below. It means whether it is to be opened, the flap, the hole, or to be closed. The control unit is the pivoted lever. The control unit is the lever. The control unit is this the lever. The correction unit is the flap opening or closing. Correction unit is the flap opening or closing. Correction unit is the opening or closing. So process unit the water level in the tank to be processed up or down accordingly, right? And then the measuring device is which one? Floating level of the ball. Here it measures where it is, up and down, right? It matches the up and down points. So this matches here, up and down points and tells. Right? Measurement device is a hole, processing device is a lever, controlling device is a pivoted holes to flap to which one it is open or not. So this we understand in a simple format. See, the comparison element, the lever, again I will tell you here, a simple, a lever, a control element, that is what? A correction element, the flap, whether it is to be open, the flap to be open, otherwise to close, the process element, the water level, up, or otherwise in the down. So as usual, the measuring, the ball and the lever, the measuring elements. So likewise, we should complete these 5 elements which makes the closed loop system. Right? So we can summarize the session. We summarize the session in this session. We have given an introduction of a system. We continue about the system. We have seen the open, and today we have seen about the closed. About the closed. What it contains? It contains, we can write here. It contains a comparison element. Then it contains a control element, a correction element, then a process element, then finally a measuring. So this become a closed loop again. So likewise, we have seen today's class about the closed loop system. The remaining part we will see in the next session. Thank you.